If you go back, you can see here, if the major axis is vertical, your focal points, you don't change the h, but you add c to the k and you subtract c from the k. Okay, so you can see that we did that on this graph. All right, the other thing from this last slide that I want to point out is the idea of the length of the major axis and the minor axis. So this says that the major axis has a length of 2a. So major axis is 2a. Minor axis is 2b. And if you look at those examples that we did, so the major axis is the longer of the two. And a was the number that I went from the center to the left or to the right or up or down, depending on which way the major axis was. But it was the longer distance that I went. And so in this case, I went a to the right and a to the left, which means that my major axis ended up being 4 units this way and 4 units that way for a total of 8 units. Okay, so you can see that that was 2 times what A was. 2 times 4. 8 units is what the major axis was. The minor axis, I went 3 up, 3 down, because my B was 3. And so that's 3 and 3 for a total of 6. The minor axis was 2 times B. And again, you'll see that same thing on here. So A was 4. The major axis is 8 units long. And B was 2. The minor axis is 4 units long. Double that. Okay, so those were just a few things. Again, those aren't big important things when it comes to graphing, but they will come in handy in the next section. So it's good to see with the graphs because then it makes the next section stuff make more sense. If you actually look in the textbook, they go through the writing the equations before they go through the graphing. But to me, I think it's better to have the visual of how the graphs work, and then you can figure out the equations a lot easier. All right, so last 2 examples we're going to have is we've got these equations that are not written in standard form, for standard form of an ellipse. Okay, so first of all, I want to discuss how you can recognize what type of equation this is. So looking at this, we need to first identify that it is an ellipse, and it does say in the directions that this is an ellipse, but in general, I want you to just be aware of what it takes to be an ellipse. So when it's all multiplied out like this, you can recognize even then that it's going to be an ellipse basically with 2 pieces. So first of all, notice that you've got an x squared and a y squared, and it's a plus between the two. Your x squared and your y squared terms are both positive. Okay. There will be instances where one of them would be negative, and that's going to be a different type of conic section that we'll talk about in a later section. So you've got the x squared and the y squared, they're both positive. The other piece that tells you that this is an ellipse, so with just those things, with the x squared and the y squared and both being positive, it could be an ellipse or a circle. So then the distinction between the ellipse and the circle is you'll notice that the coefficient of the x squared and the coefficient of the y squared are different. And if that's the case, then it's going to be an ellipse instead of a circle. And as we go through the process, the process of getting this in the standard form, you'll be able to see why that creates an ellipse instead of a circle. All right, so we have done this where we write the equation of a circle from this form to standard form, and most of the process is going to be the same. So there's just a few differences when it's an ellipse instead of a circle. So the first thing we're going to do, just like we did with circles, is rearrange the terms that I have. So we're going to take our x terms and put them together, and our y terms and put them together. So 4y squared minus 8y And then make sure that your constant term is on the other side of the equation. In this case, it's already there. So in that regard, we're already good. But just make sure of that every time. Okay. Next, what we do is if there's a coefficient in front of our y squared terms or our x squared terms, it's possible to have a coefficient in front of both. With circles, we didn't really see that, but with ellipses, you're going to see it for sure with at least one of them, if not both of them. But if you have, so I'm going to group these together, and while I'm doing that, I'm going to do a couple things. So I'm going to leave a space, and hopefully you remember that that space, we're going to put a number in there that's going to help us complete the square. But so I'm doing that. I'm going to do that with my x's, and I'm going to do that with my y's. But I'm also going to, when I get to the y's, because my y squared has a coefficient, I'm going to factor that out. So then it just ends up being a y squared minus 2y. I'm going to leave that space there. And then, again, I still have that negative 13. So now we go through the process of completing the square like we did back with circles, back in chapter 2, I think it was. And so we start by taking this middle term, divide it by 2, the number, the coefficient, and then square it. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So I'm going to add 25 in here. And then I have to keep the balance. So if I add 25 on this side, I'm going to have to add 25 on this side. All right, now I'm going to do the same thing here. So negative 2 divided by 2 is negative 1, and negative 1 squared is 1. So I'm going to add 1 here. Now, here's something that we didn't have to worry about with circles that we do have to pay attention to with ellipses and then with hyperbolas that we're going to talk about in a later section, is with circles, we didn't have numbers out in front of our parentheses, but with ellipses and hyperbolas, we do. And here, I put a 1 here, but because that was inside of parentheses and everything inside that parentheses is being multiplied by 4, what I actually added sorry about that. What I actually added to the left side of the equation is 1 times 4. So I actually added 4. So if I added 4 to the left side, I have to add 4 to the right side. Okay, so that's one extra step that we didn't have with circles that we're going to have with ellipses and then with hyperbolas when we get to those. All right, but now this equals x minus 5 squared. This is 4 times x minus, oops, sorry, not x, y. Oops. Okay, so let's try that again. Y minus 1 squared. And then that equals, so we had negative 13 plus 25 plus 4, which is 16. All right, now with circles, we were done. That was standard form. But you'll notice this is an ellipse because this, well, you're looking at this, this isn't a circle because circles didn't have these numbers in front of parentheses. So here I just have 1 here, but sometimes we'll have 1 here as well. So that's going to be the key distinction between a circle versus an ellipse. So when you have those coefficients in front of one or both of your x or your y, then we're going to need to take this a step further. And to put it in the standard form for an ellipse, we need to get it equal to 1. So to do that, I'm going to divide by the 16, and that's going to get me x minus 5 squared over 16, plus this can simplify down, that simplifies down to a 1, that simplifies down to a 4. You always want to simplify down so that your coefficient ends up equaling 1. Okay, even if it requires you to put a decimal in the denominator, that's okay. You always want to end up with your coefficients being 1, and then it equals 1. All right, now we've got this in the same format as the other ones, and so now we can graph it using the same process we were doing on the last 2 problems. So we find the center, which in this case is 5, 1. So we go over 5, up 1, And then we look under the x values, and that's a 16, which is 4 squared, so you're going to go to the right 4 and to the left 4, because that was under the x's, right and left is x's. Then under the y is going to tell you how much up and down you go, and that's a 4, which is 2 squared, so it's up 2 and down 2 from our center, and then we draw our ellipse. Now in this problem I just asked you to graph it, I didn't ask you to label it, so there's the graph and we're done with this. Alright, last one, same thing. Go ahead and try to do this one on your own, so maybe just pause the video for a second, try it, and then unpause it and check yourself. Otherwise, just keep watching if you just feel like you need an extra practice with me. So the first step I'm going to do is rearrange so that I've grouped my y's together and my x's together. And I also make sure that it's my coefficient. Sometimes the constant term, sorry, not coefficient, constant term is on the left side. If it is, you want to move it over to the right side. All right, then I'm going to do my groupings. And if there's a coefficient in front of your square term, you want to factor that out in this step. You're also going to leave a space for that number that we're going to add in there to complete the square. Again, there's a coefficient in front of my y's, so I'm going to multiply that out and get that. And then we continue on. So negative 2 divided by 2 squared, that's going to be plus 1. Negative 4 divided by 2 is negative 2 squared is plus 4. And so then again, what we add to one side, we have to add to the other side. So I added a 1 over here. I also added a 16. So that gave me x minus 1 squared plus 4 times y minus 2 squared equals, then I had negative 13 plus 1 plus 16, which gave me 4. Make it so it's equal to 1. X minus 1 squared over 4 plus, those simplify down. So then I get y minus 2 squared over 1 equals 1. And then it's graphing. Your center is at 1, 2. And then underneath the x's is 4, which is 2 squared. So that's left 2, right 2. Underneath the y's is 1, which is just 1 squared. So up 1, down 1. Draw your ellipse. And that is it for this first part of the section.